we get into Provizio, I was going through the website, I was looking at the tech, and there's quite a lot of terminology that I'm not familiar with. I don't understand. Obviously, AI is there. I get that. Could I just ask you a few tech questions just to set a scene for our listeners so we kind of know what you're talking about when we get into how it's solving the problem?
Sure.
I mean, I don't know if you were familiar, Joan, with L1, L2, L3, L4, L5, these layers of automation in cars and how that impacts what you're doing. So maybe if you could talk through that and 5D perception.
Yeah, absolutely. And you know what? The two things you mentioned, you have a very good excuse for not understanding them. And the first one being the levels of autonomy. And the reason I say that is because they don't make a lot of sense. They were developed before we truly understood the complexity of the problem. And really what level 0 is basically a car with no sensors that drives, by human control all the time, right? And level 1 is where you start to, add things like cruise control and things like that, right? Level 2 is where you start to allow, but hands-on, eyes-on driving, but you're now moving to a stage where, you've got lane centering and adaptive cruise control. So a little more automation in the system and automated emergency braking in a dangerous scenario. But then here's the problem, right? Because it goes to level 5, but it's a bit like that Microsoft progress bar that moves to a certain point and you go, at 20% of the way, but I'm sitting at 20% for the last couple of years. And that's actually what's happened. Level 3 is where you've hands off and eyes off driving, right? So that's quite a leap. So you hear an awful lot in the sector and out there in the news about autonomous driving, but 99% of automotive companies and in the space are still stuck on level 2. And the reason is it's so significant. You're talking about changing an entire industry. When you go to taking your eyes off the road and taking your hands off the wheel, something else is responsible for driving now. Up on, while my hand's on the wheel and my hand's on the pedal, I'm in charge here, right? I'm responsible. My insurance is covering me. So it's a monstrous leap. Level 4 then is where in certain scenarios, the vehicle's fully autonomous, right? Or in certain regions, for example. So that's where you something like a Waymo vehicle that we're all aware of that, San Francisco can drive fully autonomous without a driver, but in that area, right? It can't move up the road. And then as you go towards level 5, that's where it's ubiquitous autonomy. The vehicle can drive anywhere it wants with no driver. In fact, there's no steering wheel, right? And that's really where you go. So they're not equal, right? I think the goal is to get from level 2 to level 3, and then everything gets a bit easier from there. I hope that makes sense.
No, totally does. Question to kind of root this in to what people see on TV in between the shows they're watching. It's something called a commercial. A lot of people pay to avoid them. Some people have to watch them. But there's one
in 20 years.
There's one, I can't remember if it was GMC, Chevy, I don't remember, whatever, but there's the we will rock you Queen song, and they're going don't like doing this with the hands off the wheel in the truck. Is that 2 or 3? Where are we at with that?
It depends. How long are they keeping their hands off the wheel?
I mean, there's a quick cut of them doing it for maybe 3 seconds, but largely they're telling the story of maybe the whole trip into the mountains could be done with a looped "We Will Rock You." I don't know.
Yeah, so that's level 2 in the main, right? Because if you're taking the hands on and off the wheel, you can do that with level 2 driving systems, but your eyes are still on the road and things like that. And it's different rules in different countries, right? So in Europe has different rules to the United States, but true level 3, those hands aren't going on and off the wheel, and those eyes aren't focusing on the road as in certain scenarios. So it's another leap. So like everything, it's a new flavor of level 2, and you'll hear people talk about level 2 plus, And really that's because it's a bit more level 2. So the guys that allow you to take the hands off sometimes, that's a bit more than the guys who, never let you do that. But again, the descriptors are bad, I would say, using these levels.
If I lived in California, could I buy an L5?
No, you can't buy an L5 anywhere in the world, just so we're very, very clear. In fact, I'm not aware of any L5 programs in the world. I mean, Waymo is number one in autonomy. It just absolutely ahead of everybody. But they're level 4, right? Or maybe level 4 plus, because now they're in multiple cities. But when Waymo will be at level 5 when they can cover the whole United States and not have to worry about anything, right? Whereas now they're in pre-mapped environments that they understand. So I would consider that level 4.
Okay.
So the one interesting thing about frameworks like this is, so we have a book club, and one of our books we read, The Nexus by Julio Tino, and he talks about grounding new things in the old way of doing things, right, to make them relatable. So frameworks can be interesting in that regard. Sounds like this one is a little lacking, a little confusing too, but like where are you guys headed related to your work? And let's talk about some of your specific technologies that you're developing.
Yeah, no, that's a good segue into how we see the world. I guess we don't see the world in levels of autonomy. That's not how our customers do, of course, right? They have to sell and they have to adhere to certain criteria. But we decided to look at the problem maybe from the different ends, right? And what I mean by that is it helped having a background in airways, right? So if you go to NASA tomorrow with a new technology, right, and you say, I want to bring this technology to space, and but now it's made from a material that obviously can't go into space. That's the end of the conversation with NASA, right? But if you think of the autonomous vehicle industry, that's exactly what they did. They were like, well, we can drive it around in circles on a track. If it rains, we have to pull it in. That to me, it just wasn't the path to go here. So we said, let's look at it from the opposite side. Let's focus on the hard bit first, right? And as it happens, the hard bit in autonomy is also the bit that we as humans find hard, right? And the edge cases, they're often called in robotics. And really, these are the things that lead to crashes and things like that. So we started looking at, well, what level of sensing would you need to actually solve the driving problem, stop us crashing into each other, give people the foresight to prevent crashes. And if you solve all of those, well, then autonomy becomes a byproduct, because then it becomes an ethical question. If I can prove that my sensors and softwares and brain are better driver in these scenarios than you are, then that to me is a much more compelling case, instead of telling the world, hey, we're going to kick all truckers out of trucks and just have them autonomous to save money. That to me wasn't interesting. So that's kind of how we looked at it. And that's where 5D perception, and Conscious Mark asked a while ago, what the hell is 5D perception? And it is an abstract term, but it came from that. It was basically, to solve the problem, you need to be able to see the whole world and understand the whole world in 3D, right? So that's 3 dimensions we all understand. The next dimension is range and velocity, right? So I can see the world, and like human eyes, we can see a car coming towards us, but we actually have to guess what speed it's coming at, and we've got to guess what distance it's at. Then make a guess of, can I get out in front of it? And we often get it wrong, right? So you have to understand that 4th dimension. You have to understand the range and velocity of all objects. And the 5th dimension, that's our abstract term, that's the understanding. Whether you call it AI, whether it's machine learning, whether it's digital signal processing, but making sense of all that data. That 3D object is a car. It's moving at this pace. There is a pedestrian about to step out. There's going to be an incident. That's the 5th dimension. That's that understanding. So that's how we kind of flipped the problem on its head and said, well, let's focus on solving the problem. And then in those scenarios, and that's why the levels go out the window, right? Because actually you will have a car that will jump from level 4 to level 2, or, by those definitions at different times, depending on the scenario. So I'm here in the southwest of Ireland, in Shannon, right? And you may have heard the rumors, but we get a little bit of rain here, right? We also get quite a bit of fog, right? And so in a foggy environment, for example, I can see about 10, 20 meters if I'm lucky, right? And on a nice morning here, our sensors can see 600 meters in that same fog. So in that scenario, the vehicle should be driving itself, not me. I can see 10, 20 meters. What use am I in that scenario? Whereas the vehicle can see 600 meters. So we can make much better decisions. So suddenly in that fog situation, it's gone to level 4. But when the fog lifts, statistics say I'm still better now in good conditions. I'm a better driver than the machine. So therefore, we work together and it becomes level 2. So that's kind of just a slightly different way of viewing the world as we see it.
I love going.
Just playing on that though, in the future, is there a point when ethically you're never better than the machine at driving?
Absolutely. That's what we're going for, right? But then it becomes it doesn't become a debate at that stage. It becomes statistical data. I have the evidence. I'm better than the human driver in this situation, which is kind of, I think, where the industry got it wrong in the beginning, right? And then people started having the ethical debates. The trolley problems often brought up. Do I mow down the little old lady crossing the road, or do I swerve and hit the kids? Hey, how about we see the little old lady a couple of 100 meters away, and and let's not kill anyone, right? And I think that it seems so right. I mean, we're laughing, right? Because it just seems so bizarre, but it's so logical, right? That's how you would approach it. So you need better perception, and that's really what we're all about in Provizio, is to build that.
Super interesting. So number one, I love that you're tackling the hard shit first. Like, I think that's very commendable, and just saying, let's go after the big stuff. And so understanding the world around you, yes, seeing what's out there, but the range and velocity thing is interesting, right? Because we're all pieces and parts moving in that world. So that makes a whole lot of sense. But having these sensors that could actually deliver the information that you need is really interesting as well. I start thinking about in planes like IFR and VFR, like instrument flight rules, visual flight rules, like, and the delineation of, like, obviously when you can't see and you're flying an airplane, you have to go instrument flight rules. But what are the give us a couple more examples of when the tech that you're actually working on and testing and delivering, what are those scenarios where it helps you make that switch?
Yeah, absolutely. So there are hundreds, right? But just to kind of give some other examples, our backbone in our technology is radar, and we're very radar focused. And the reason for that is there's loads, like, cameras are on every vehicle, and there will be, and we work with cameras obviously very closely. And then you've LiDARs, was another technology that was developed, but LiDAR has a lot of the same weaknesses the camera has, right? And what humans have, right? So cameras can see like a human can. So we can see the vehicle in front of the vehicle, for example, in front of us. And we can't tell, as I said earlier, the exact velocity. So a very interesting example of how we use the technology is radar, that millimeter waves, right? And they literally bounce up around the vehicle and then onto the next one and onto the next one. And those waves send back the signal on the image of the vehicle, but also gives you as I said, the range and velocity. So you know what every vehicle is doing. So when you have multiple vehicles ahead, humans can't tell what's going on a couple of vehicles ahead. Cameras can't tell, a LiDAR can't tell because of shadowing, but we can, the radar can. So for example, we've all been there, especially in country roads in lots of different countries, where you're stuck behind someone and you go to make that overtaking maneuver, but you're blinded to the vehicles coming towards you as well. The sensors can see all of that. And these are some of the early implementations we're seeing with our OEM partners, where it gives you a gentle nudge as a driver. So you go to make that overtaking maneuver, it stops the wheel. Then you see that car go past you and you go, oh, I'm so glad that there's artificial intelligence built into this that saved me from myself, right? And now suddenly I trust the robot, right? As opposed to when we actually use hands-off driving, humans get very nervous. They've done the measurements on our brains. Like when we hand over control, we're not really good at it. It's why people are scared of flying, even though it's so safe. So when the machine starts to save your life on a regular basis like that, that's where we think that impact will be significant. Another one that I can give you is more than 50% of car crashes are rear endings, right? So why do you drive into the guy in front of you or the guy behind you drive into you? It's because of lack of foresight, right? If you could have seen that something was going to happen, you wouldn't have hit them, right? And so in that scenario, we can see the car, let's say 6, 8 cars ahead of you. We can see that car start to decelerate before his brake light come on, right? That's what the technology allows you to do, because we've basically got his exact velocity. And so normally you have to wait till the car in front of you's brake light. So you can imagine the latency in that, right? It's 1 car, 2 cars, 3 cars, 4 cars, and then bang. So if I'm able to see that so much earlier, I'm able to take preventative action. So I'm able to slow down in a manner that the guy behind me doesn't hit me either, right? So those are 2 kind of just very simple type scenarios that if you have the right sensors, you're absolutely going to be better than a human driver.
One of the experiences I've had of late,